Okay, just so that we can understand what we are looking at in this review of angle pair relationships, we want to make sure that we check every definition of angle pairs in order to define whether or not, or decide whether or not angles 1 and 2 are one of these types of pairs. So when I'm looking here at angle 1 and 2, I can see for sure that they are definitely formed by these two intersecting lines and that they are across from each other, which makes them vertical. They are definitely not adjacent because they do not share the same side. There is no information to indicate that they are complementary because there is nothing there to say that when you add them up that they will add up to equal 90. Likewise, there is no information there to say that they will be supplementary, and they do not form a straight line together, so they are not a linear pair. So the only choice here is that they are vertical. When we're looking at angles 1 and 2 over here, we can see that this angle was marked as a right angle. That means that angle 1 and 2 combined also form a right angle, so I marked that. And then I'm going to go from there. They are adjacent because they share this line. I'm sorry, they share this side. I should clarify that they share this side. Definitely adjacent. And because the two of them together form a right angle, that means that they are also complementary. Their angle measures together will equal 90 degrees. Moving on to question 3, we can see that angles 1 and 2 together form this straight line. They also share this side. So if they share a side, we can mark them adjacent. They form a straight line, which makes them a linear pair. And every linear pair, of course, adds up to equal 180, so they are supplementary as well. On question 4, we can see that angles 1 and 2 definitely share a side, so that makes them adjacent. They are definitely not vertical. Vertical angles are never adjacent, by the way, and likewise adjacent angles are never vertical. Complementary, there is no information to indicate that when you add them together that they will equal 90 or that they form a right angle. Likewise, they do not form a straight line or add up to equal 180, so they are neither supplementary or a linear pair. Question 5 is interesting because there are a lot of marks here. You can see that angle 1 along with this adjacent angle form a right angle because it's the other side of this right angle that's marked right here. So if they are congruent and form a right angle, I think that you could say that you could split 90 degrees in half, or in other words, divide this 90-degree angle by 2, and you have two congruent angles, which means that mathematically that works out such that angle 1 along with this congruent angle each have a measure of 45. That's good to know. We'll keep that there. We know that angle 1 is vertical to angle 2, which makes them congruent. So they are vertical. The reason why they're marked complementary is because if they are congruent, and we already determined that angle 1 is 45, angle 2 would also have a measure of 45, and 45 plus 45 is 90, which makes them complementary. On this side, we can see for sure that angle 1 and 2 are vertical to each other. Angle 1 is a right angle, as you can see by this marked right angle, but so is angle 2, right? So that would mean that this angle has a measure of 90. Angle 1 has a measure of 90. So does angle 2, which means that they must also be supplementary because when you add them together, they equal 180. Question 7 was interesting because you have 3 angles marked with different expressions. I started with the 2 expressions that have 3x plus 4, 10x minus 19 because they share the same variable, and combined together you can see that they form a straight line, which makes them a linear pair. If these two angle measures, or if these two angles are a linear pair, then their measures added together would equal 180, which is what I wrote here. You can see that I added those two angle measures together and set them equal to 180. Once I solved, I found that x then equals 15. So then you can plug this solution into this expression for this particular angle, right? So 10 times 15 minus 19 is equal to 130. It's important to understand that if we have this angle measure, then we have this angle measure because these two angles are vertical to each other. So that would mean that 8y minus 13 also equals 180. So I then wrote out that equation here and solved for y to get y is 18. Question 8 also had a lot of given information in it. We can see that this angle was marked with the expression 3x minus 23, and this angle was marked as 9x plus 3. Now, I marked these two angles, this angle here and this angle here, as congruent because they are vertical to each other. So that would mean that the measure of 3x minus 23 is also the measure of this angle over here is 13x minus 23. So this angle that is marked 13x minus 23, now that I know these are congruent, added with this angle, 9x plus 3, will equal 90. And the reason why I know that is because they told us at the very beginning that these two segments are perpendicular, so they form a right angle. So when I add 13x minus 23 with 9x plus 3, I will add them up and say that they equal 90. And solving for x, I will get that x equals 5. Now that I can plug this in over here, that will help me find the measure of this angle. So 13 times 5 minus 23 gives me 42. And that helps me because I'm looking for the angle measure JNM. Now this angle plus the measure of angle JNM form a straight angle here. So if I add 42, which is the measure of this angle, with whatever this is, I'll get 180. Conversely, that means I can just say 180 minus 42 gives me the angle measure of angle JNM. So that will give me 138 degrees. Finally, on this sketch, we had a lot going on, and I marked a bunch of congruent angles here. I took the liberty of marking vertical angles congruent to each other, so these double blue marks are angles that are vertical, so they are congruent. The single red marks are vertical, so they are congruent. And then these triple green marks here are vertical, so they are congruent. I wanted to do that because I wanted to show that if I add the measures of these three angles together, you can see that they have to add up to equal 180 because all three of those together form a straight line. If that is true, then I can also say that if this angle is congruent to this angle that has a measure of 37, then this angle also has a measure of 37. So I just added essentially 6x minus 3 plus the 37 plus the 3x plus 29 and set it equal to 180. Solved to get x equals 13. Now that I know that x equals 13, I can plug that in here to get 3 times 13 plus 29, which equals 68. So I can get this angle measure. This angle measure is 68 degrees. That's awesome because this angle measure is the same as this since they are congruent. So I can say that 10y minus 12, this angle, equals 68, and then solve for the y.